Okay, Math 098, we are working with Chapter 9, which is all about exponents and logs. But before we get into exponents and logs, we want to talk about what are called composition functions. And there's a reason why we want to talk about composition functions before getting into things that these are actually inverses of each other. And what you can tell is when we get to a composition function, which looks something like this, f of g of x, which I'll explain here shortly, is if things are inverses of each other, the compositions will cancel each other out and you'll be left with just x. So this is not always going to be the correct answer unless f and g are inverses, which we will get to down the road. So the first thing that they want you to recognize in section 1 is if you have two functions labeled like this, f of x and g of x, then we can do any kind of operation that we want with them. So this is just the shorthand for saying the same thing as take the f function and add the g function to it. They just write it a little bit different. It kind of looks like the distributive property, right? But anyway, all you have to do is take the f function, which is labeled as x plus 2, the g function, which is labeled as 3x plus 5, and add them together. Some teachers will have you put parentheses in there to show you the substitution, but you don't have to do that for this type of problem. I'll talk more about why you should when we get to letter B. But anyway, we're still not done because we want to combine like terms. X plus 3x is 4x. Those are like terms. We can combine them. And 2 plus 5 is 7. So there's your first answer. So let me change colors and explain why in letter B you want to use parentheses. So it's really set up the same way. This is shorthand for saying the function f of x minus the function g of x. We can write it either way, so make sure you're familiar with that. So this time I want to use parentheses because, let me copy it down first. F is x plus 2. G is 3x plus 5. Because you have to distribute that minus to both terms. Now some teachers will actually show you the minus 3x minus 5, but I think you guys are also smart enough to look at this and say, well, 1x minus 3x is negative 2x, and 2 minus 5 would give me negative 3. But if you prefer using the like terms, that's fine. 1x plus negative 3x is negative 2x, and 2 plus negative 5 is negative 3. I guess I should highlight that those two are like terms as well. Yeah, so if we can add and subtract functions, then we can also multiply and divide. That's exactly what's going on here. If there's no operation in here, like you don't see anything, it's implied multiplication. So why are we doing this all the way in Chapter 9 is to remind you that as you substitute x plus 2 in for f of x and you substitute 3x plus 5 in for g of x, you have to distribute all of the terms. So we're looking at 3x squared plus 5x, and then distribute the 2 in there. So plus 6x plus 10. But also, just like in A and B combine like terms, we have like terms here in the middle of 3x squared plus 11x plus 10. And as always, if you are confused by anything, please write down your questions and bring them to class. That way I can answer them and get you squared away. Yeah, you got to let me know if you have questions. And same thing with letter D. This is shorthand for saying the function f divided by the function g. So in this case, what we can do is replace x plus 2 over 3x plus 5 and simplify if you can. The problem is nothing is factorable in this problem. Again, this is why we're doing this in Chapter 9. Just a few chapters ago we talked about rational functions, which is exactly what this is. But there's nothing to simplify, so this is all we can do. You might have a teacher down the road that might ask you to give the domain which, as you recall, the denominator can never equal 0. I don't want to commit to saying you don't have to do this. And then maybe in the directions on the test, I ask you to state the x values that make the function undefined. And that would be, x cannot be negative 5/3 because then we'd be dividing by 0. So keep that in the back of your mind as we're learning some other stuff. So this is your new lesson. And you may have already learned this before. By the way, I couldn't find the button on the keyboard for this program that makes it actually look like in the book. So if you're reading the book, it's like a tiny O in here, f of g of 4. And over here, it's saying f and a tiny o of g of x. Anyway, what this is really saying is to do this. You may be familiar with this instead. So f of g of 4 can be written this way, f of g of 4. Well, what you do is you do the g function and you plug x equals 4 into that function first. So I've seen teachers that say do composition, that's what this is called, right to left. I don't really like that though, because everywhere else in math we read things left to right. So what I prefer teaching is that you do the order of operations, where you do inside the parentheses first. And that makes more sense to me. So if I go to this function and I plug 4 in for x, I'm looking at 3 times 4, which is 12, minus 5, which is 7. So now what I can do is replace g of 4 with 7. Again, please write down your questions if you have any, and bring them to me. So now what I can do is go to the f function and plug 7 in for this x. Well, 7 squared is 49 plus 1 is 50. So this first answer, I didn't give myself much room, is 50. So you might be thinking, well, addition and multiplication is commutative, so does the order really matter? And that answer is yes, absolutely. So again, this is read as g of f of 4. And so sometimes you'll see it written like this, g of f of 4. Be familiar with both, because you never know, I might switch it up on the test. So if you do inside the parentheses first, you go to the f function and you plug 4 into that. Well, 4 squared is 16 plus 1 is 17. So I get to replace f with 17, and that g is still there. Well, now it's telling me to go to the g function and replace that x with 17. So we're looking at 3 times 17 minus 5. And I just want to double check I get the right answer. I should have hit pause so you don't have to wait for this program to load up. There we go. 3 times 17 minus 5. You get an answer of 46. So you definitely get a different answer with a different order. Same number, but different order, you'll get a different answer. So yeah. So how can we make it a little bit more difficult? You might be saying that was pretty easy. Well, what if we just throw in a variable in here? So we ask you to do f of g of x. Well, what that tells you is you're putting the entire function of g of x into the other function. So this is basically saying the same thing as f of 3x minus 5. And so what that means is I need to replace the x in this problem, this x, with 3x minus 5. So sometimes what you'll actually see me do is I'll just write out the function without the x. See how I'm replacing this x with 3x minus 5, so I need to replace this x with 3x minus 5. Okay. And every year I teach this, somebody is still confused. So if you're confused by that, please write down your questions or plan to, touch base with me on what your question might be. Yeah, so let's look at this last one for exercise 2. We're looking at g of f of x. And again, the order matters. You want to plug in the f of x function in for g. So sometimes what I'll do is I'll just rewrite that f of x is equal to x squared plus 1. And we still have the g function of that. So now I'll move to the g function, and I'll just take out this x. See how I just rewrote 3 something minus 5, taking out the x, and now I can replace that x with x squared plus 1. Now, if you notice, I haven't been simplifying these answers because I'm more concerned about, do you understand the order and how the order matters? If you check your answer with the back of the book, you might actually see this answer written as distributing the 3 in there. So it'd be 3x squared plus 3 minus 5, so it'd be minus 2. At this moment, I'm less concerned about you simplifying these problems. I'm more concerned about do you understand the order and how the order matters. So just so you're aware, your answer when you do the homework might differ from the answer that you write down. Well, I think I said that wrong. The answer you write down might be different than the back of the book. Okay. So I think I have enough time before my 15 minutes is up to do exercise 3, but it's really the same practice. Does the order matter? And that answer is yes. So you can pause the video and try this on your own. But the way I like to think about it is to do g of x first. So I'm just replacing g of x with what it equals. That's x minus 2. And the f is still there. So now I can go to the f function and just take out this x. So it's the absolute value. Hopefully this absolute value is showing up on your screen. I know sometimes it doesn't show up. And I need to replace that x with what's inside the parentheses, x minus 2. So that's your first answer. This is f of g of x. So just to change colors and show you g of f of x. What you're doing here is you're replacing the f of x function, which is the absolute value of x. And then the g is still there. So now I go to the g function, and all I'm doing is I'm taking out the x. And I'm going to replace that x with what's inside the parentheses. It's the absolute value of x. Now you might be sitting there and saying, well, I don't really see much of a difference between those two. Well, let me just show you with a graphing calculator that there's a huge difference between those two. So my graphing calculator, I'm just going to pull up a graph. And I can grab the absolute value under the math tool. There's a lot of different places you can find it. But absolute value of x minus 2. Double checking that that's the correct equation. If I look at my graph, it was shifted to the right 2. And if I were to look at a different equation where it's still the absolute value of x, but then the minus 2 is on the outside, what you'll notice is that this graph is shifted down 2. They are definitely different. Now some of the answers are identical, answers from 2 to larger, but for all the other numbers, the order matters. Let's see, I don't want to rush through exercise 4, plus it's a fairly difficult problem. So I will explain that quickly in a second video. And here's your assignment that if you want to try some things and then come back and watch a second video, that's fine. But I definitely need you to practice exercise 4. So hopefully you come back and watch that.